7.4, we're going to be solving logarithmic equations. And I'm going to revisit something that we did yesterday. So the next slide is actually the first slide from yesterday's notes that I want to talk about a little bit more in depthly because I really kind of didn't talk about it yesterday.
You want us to put it in our notes?
So yeah, if you want to, you can. So this is the first page from 7.3 yesterday. Okay, it's exactly the same slide, except I highlighted a couple things that I didn't talk about yesterday. Namely, when you have logarithmic form, this b and this x must be positive numbers. Okay? They must be positive, and b can never equal 1. And I didn't talk about that yesterday, and it's going to come up today. Because one of the things that's going to happen, and we're going to check our answers to some of our equations, is sometimes x is going to equal a negative when we solve. But in a logarithm, this x and this b can never be negative. So as you're about to see, if that ever happens and a solution ends up making one or both of these numbers negative, then we throw that solution out because it can't be negative. And I didn't talk about that yesterday because it really wasn't in play yesterday. But today when we solve logarithmic equations, all right, this is going to come into play, and we got to just look out for that. Those numbers can't be negative. If you ever find something that creates a situation that makes one of those numbers negative, then we have to throw that solution out. And we'll talk about that here as we proceed through these lessons today. Okay? Now, here's the type of equation we're going to be solving. Okay? So I have a anytime we're solving equations, there's a variable. We're going to try to figure out what that variable stands for. And in this case, should this x end up being a negative number, we're going to throw that solution out because we're not allowed to have either of these two numbers be negative. Okay? And our strategy, there's two different types of equations that we're going to look at. We're going to look at ones where there's only one log like this. Okay? And when there's only one log, all you've got to do is you rewrite it in exponential form like you did in 7.3. Okay? So go ahead and do that. Rewrite this equation, because it's in logarithmic form, rewrite this in exponential form, and let's see what you come up with. All right, so when I put this in exponential form, this just means, again, you kind of cycle this way, right? 9 to the 3/2 equals x. Now, we had a little trouble yesterday remembering how to deal with those fractional exponents. What does this bottom number mean?
This root.
Yeah, the root. And since the number is 2, we're talking about the square root. And then the 3 means I take all that to the third power. So what you would want to do, now in some of your cases you might just punch that in your calculator and fine. In others, I'd like you to write it out. This means the square root because if you remember, there's a little 2 as the index there. And that 2 lines up with that 2. And then the 3 goes on the outside. And this is what we did in chapter 6. Okay? So what is the square root of 9? 3. Okay? So really that's 3 to the third, which is what? 27. So it equals 27. Now, we have to do a quick little check because, again, we have to avoid negatives. If I plug 27 in here, are either one of these numbers negative? No. So we're good. That's our answer. That's what you need to do for your check.
Close enough.
Okay? So when you have one log, only one log, all you're going to do is put it in exponential form, just like you did here, just like you did in half of your problems in 7.3. Okay? So that's that one type of problem. The other type of problem that you're going to look at is when there are two logs, when there's a log on both sides. Okay, and here's how we're going to deal with that. So here's that problem. Okay, so I have log base 3 of x squared minus 15 and log base 3 of 2x. Okay, so I have a log on each side and the base is the same, which is good. So what we're going to want to do here, and these ones can be sort of easier, but then they can also get a little more complicated after a bit. Okay? So what we want to do is if there's two logs, you just cancel the logs out. Alright, so I can ignore that and ignore this when it's log equals log. Okay. Again, this is a different type of equation because it's log equals log. The first one only had one log, so we do that differently. So in this case, all I have here is x squared minus 15 equals 2x. Now, we're going to revisit chapter 4 a little bit, because in chapter 4 we solved quadratic equations, which meant we did some factoring and we used the quadratic formula. It's been a little while since we've done this, okay? But you are going to have some problems like this. So we're going to revisit it a little bit, right? Whenever I have an x squared term, that means I have a quadratic. When that happens, do you remember what you need to do to solve?
You do. Like, isn't it like negative b root?
Well, that would be the quadratic form, but we're not quite ready for that yet. We have to do something first.
Simplify.
Not yet.
Put it.
Place all the x's on one side.
Oh yeah.
On
Well,
the
you
other
have to
side
get
of
the
equals
x
sign.
on that side. Switch the 2x and the negative 15.
No, you're real close. You're both really close. Yes, all of that is true. That is true too. But what does one side have to equal?
0.
0. One side has to equal 0. So you're right. I do have to move the 2x to the other side. But the 15 is going to stay there. The minus 15 is going to stay there. Okay, and then we do have to put them in order from x squared, x, and the constant term. When I move the 2x to the other side, what happens to it?
Turns negative.
It turns to negative. Notice how I put them, I put the minus 2x now in between, so it goes x squared, x, and then the constant. So I made the one side 0. Now it's in standard form. It's in descending order, x squared, x, constant. We have two choices now. At least two choices, okay? Actually, there's more than two choices. You could plug this in your graphing calculator and see where it crosses the x-axis and find your solutions that way. Okay? You could use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Or you could try to factor. And any of those are available to you, and any of those things you are supposed to know how to use and do. Okay? Now, I prefer factoring when it's factorable because I think it's quicker. And let me show you for this case why I think it's quicker. What are the factors of negative 15?
3 and 5.
Negative 3.
Negative 3 and 5, so I have these options. I have negative 3 and 5. What do those add up to?
2.
Positive 2. What do I need them to add up to? Negative 2. So I need to switch them and just make it 3 and negative 5. And now they add up to negative 2. Is this all ringing a bell?
Yes.
Does it all seem familiar? Okay. But you can use the quadratic formula and you'll get the same answers. Okay, that's okay. You could plug it into your graphing calculator and the x-intercepts will give you the same answers. That is okay.
Did we do this on our midterm, or is this going to be on our final?
Logarithms will be on your final.
No. Factoring the quadratic.
Yeah, no, that'll still, I mean, if in order to solve these,
But
if we have to use,
we
if, yes, but in order to use it in the context of logarithms, you have to know how to do it still, okay? Now, so here's how I would factor this. Since it's positive 3 and negative 5, it's just x plus 3, x minus 5, or x minus 5, x plus 3. Either way, same thing, okay? Now, here's where our next part is. So then, I have to set each of these equal to 0 and solve. So what does x equal over here? Positive 5. What does x equal over here?
What happened to 15?
Negative 3. Okay? So I have two possible solutions. 5 or negative 3. The next thing that we have to do is check them. Because again, as I talked about at the very beginning, if this x squared minus 15 is a negative, or this 2x is a negative, we're going to have to throw that solution out, or solutions. So on the next slide, I'll jump over here. Okay, we're gonna check them. So here are my two solutions that I have right now, 5 and negative 3. So I'm gonna plug the 5 in for all the x's. That's the first move I'm gonna make. So here I plug the 5 in for the x's. Alright, so that's 5 squared. That's 2 times 5. What is 5 squared? 25 minus 15? 10. So this is all 10. 2 times 5? 10. So that one's good, right? Log base 3 of 10 equals log base 3 of 10. So I know that 5 works. It didn't turn anything negative. So I count 5 as one of my solutions for sure. That's why I put my little check mark by it, because it checks. There's no issue with it. Now we got to do the same thing for negative 3 and see if that checks.
No, we don't.
Okay?
You can have a negative.
So let's look. So I plug negative 3 in. Okay, what is negative 3 squared?
It's negative 6.
Nope.
Oh,
Positive 9. What's 9 minus 15 now, Peyton?
negative.
Negative 6. Okay. And then 2 times negative 3.
Positive 6.
What's 2 times negative 3?
Negative 6.
Negative 6. So they sort of both work. However, this is that reason why I went over that very first slide again from yesterday. This number can't ever be negative. That is a problem. Okay? You could never, because let's think about what a logarithm really is. 3 to some power can never be a negative. No matter how many times I multiply 3 by itself, it will always be positive. It can't turn negative. That's why that number can't be negative. Okay? So in reality, that's a problem. Even though these two things are the same numbers, you can't have negatives in that spot for a logarithm. So what I do then, I throw out, so it cannot be negative, throw out negative 3. We just get rid of that solution, and I get one solution only. Okay? Now, this is really only going to happen when it's a problem where it's log equals log. The very first type of problem that we did, if there's a negative in the beginning, then you know there's a problem and you don't really even have to do anything. Okay? But when it's log equals log and they cancel out and you solve them, it is possible to introduce solutions that will create a negative next to the log, and that would be a problem. Okay? Questions about that? Here's the most important thing about 7.4. And I want to make sure that you're good with this. There are two types of problems. You approach them differently. So what you want to do before you even start, and I don't know the best way for you to do that. You have to choose that. But maybe when you put the problems in your homework, you highlight the ones that are only one log, one color. And then you highlight the ones like this that are log equals log, a different color. So that you know I got to do one process for this type of problem, but yet I got to do a different process for this type of problem. Okay? Because that's the part that will get you messed up. If you use the wrong method for the wrong type of problem. Keep it straight that there's two different types of problems that you're looking at. You just got to use the right method for the right problem. Okay? And how you identify those different types of problems in your book, that's up to you. But I highly, highly, highly recommend that you do that first. Okay? Good?